Welcome to the final section of Chapter 5, Section 5.6. And this actually ends up being a fairly short section as well. Maybe we can get it all done in one video. We will see. What we're talking about, our Section 5 was real solutions, or finding the real zeros of a polynomial function. This section deals with the imaginary, or the complex. And one thing we need to understand is that if we are given imaginary numbers as a solution to a polynomial, then what is called its conjugate is also a solution. And the conjugate simply means it's the exact same number except change the sign on the I value. So if it was plus 3i, then change it to minus 3i. If it was minus 17i, change it to plus 17i. And that's what questions 1 and 2 are asking. It says, suppose we have degree 4 and we know some of the zeros. One of the zeros given is 8 minus 5i, and the other is 3i. Well, the conjugate is also a 0, so the conjugate of this would be 8 plus 5i. And the conjugate of this, because this is an imaginary number also, would also be it, so that's negative 3i, because we just always change the I part, the imaginary part. And so there would be the 4 zeros. These are the 2 that are being asked for. Number 2, we're degree 6. We're told 1, 2 plus I, negative 4 minus I, and 0. And we need to have a total of 6 because we're told it's degree 6. Well, 1, 2, 3, 4, we only need to find 2 more. This is imaginary, so its conjugate is as well. Negative 4 plus I. There's one answer. And the conjugate of this, which is 2 minus I. It's very important to realize it's only the I value that changes. Don't change this to a negative. Don't change this negative to a positive. It's only the I value that gets changed. Examples 3 and 4 give us the degree, give us at least some of the zeros, and we need to find the polynomial. So we basically have to do what we did for 1 and 2. Number 3 is degree 3. We know the zeros are negative 2, 3 plus I, and we immediately know the other one is 3 minus I. There's our 3 degrees, and so now what we have to do is we have to put these into their factors and actually start multiplying things out. So putting this in as a factor is x plus 2. It's always the negation of that. And then these two will be x minus 3 plus I and x minus 3 minus I. Now realize it's going to be a whole lot simpler if you multiply these two together first and then deal with this, because otherwise you get just quite a mess if you try to multiply these two together. Multiply the factors that have the conjugates of each other together first, and that will help things out. So let's look at this one. So this would become x plus 2 times, okay, let's look at what happens here. I'm going to multiply x by everything, so I get x squared minus 3x minus ix. Multiply everything through over here by negative 3, so I'm going to get negative 3x plus 9 plus 3i. Then multiply everything through by I, plus ix minus 3i. And then this is negative I squared, but it's very important to realize I squared means negative 1. So negative I squared is equal to negative 1, which equals plus 1. So this becomes x plus 2 times. Okay, just cleaning this whole mess up, we get x squared Let's see, this minus ix and plus ix cancel each other out. This 3i and negative 3i cancel each other out. So that leaves the negative 3x and negative 3x is negative 6x. And the 9 and the 1 makes 10. And so that's what x minus 3 plus I and x minus 3 minus I equals. X squared minus 6x plus 10. But now we have to take this and multiply this. So I'm going to take x times everything here and get x cubed minus 6x squared plus 10x. Then I'm going to take the 2 and multiply by everything. Plus 2x squared, negative 12x plus 20. And then all I need to do now is to clean this up. Cleaning this up, we get x cubed, negative 4x squared, negative 2x plus 20. And so this is our degree 3 with these, the numbers given, as our zeros. Number 4, very similar. We have 2, negative 3i, so that means we have 3i. And we have 4 minus I, which also means we have 4 plus I. Now what I'm going to do is, I realize that this is going to be x minus 2. This is going to be x plus 3i times x minus 3i, and I'm going to actually multiply those out. And this is going to be x minus 4 minus I and x minus 4 plus I. And so I'm going to go ahead and multiply this out as well. So let's take the x times everything here. X squared minus 4x plus ix. Take the negative 4 times everything over here. Negative 4x plus 16 minus 4i. Take the negative I times everything here. Negative ix, positive 4i, and a negative I squared becomes a positive 1. Okay, so the negative 4i and positive 4i cancel each other out. The ix and the negative ix cancel each other out. And simplify or combining like terms, I get x squared minus 8x plus 17. So that's what this equals. Now here, this is FOILing. So take the first terms is x squared. The outer and inner terms will cancel each other out basically. And then that gets negative 9i squared. Well, I squared is still equal to negative 1, so this becomes x squared plus 9. So now I have x minus 2 times x squared plus 9 times x squared minus 8x plus 17. And so, just for my ease, I'm going to take the x minus 2 times the x squared plus 9. So, x minus 2 times x squared plus 9. And this is a FOILing. First term, x cubed. Outer term, 9x. Inner term, negative 2x squared. And last term is negative 18. Put this into its correct descending order. And that is what we get. X cubed minus 2x squared plus 9x minus 18. But I still have to multiply that by this right here. So now I have to take x squared minus 8x plus 17 times x cubed minus 2x squared plus 9x minus 18. So I'm going to take the x squared, multiply everything through by here. So that's x to the 5th minus 2x to the 4th plus 9x cubed minus 18x squared. Take negative 8x times everything here. Negative 8x to the 4th plus 16x cubed minus 72x squared plus, let's see, 18 times 8, 64, 144x. Continuing. I still need to take the 17 times everything here. So this would be plus 17x cubed minus 34x squared plus 153x minus let's see, 17 times 18 is 306. Then finally, when all of this is cleaned up and like terms added and all that good stuff, we end up with x to the 5th minus 10x to the 4th plus 168x cubed minus 120x squared plus 279x minus 270. Quite a bit of work, but we're finally to where we need to be.